Hello everyone. So today's problem is sum of all substrings of a number. You have given an integer s representing as a string. The task is to get the sum of all possible substrings of that string. Note the number may have leading zeros. Okay, this is guaranteed that the total sum will fit within a 32 signed integer. Okay, let's see. So it's saying we have to find the all substrings and that we have to add all of the substring values to get the answer. That is easy. If we take the substrings for all the substrings for this particular string, it will be 6, 7, 5, 9, 5, 9, 6, 7, 6, 7, 5, 6, 7, 5, 9, 7, 5, 7, 5, 9, and 5, 9. So 1, 2, 3, 4, 5, 6, 5, 6, 7, 8, 9. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total there are 10 substrings. As the formula for substrings is n into n plus 1 by 2. N is the number of characters, which is 4. 4 into 4 plus 1 by 2, which is 4 into 5 by 2. If you see, that is, this is 2, this is 10. So it satisfies with the formula as well. So this is the number of substrings in a given string. For formula, I can say this one. So if you add all these numbers, this, and all the substrings, if you add, you will get this particular answer. So let's see for the second one. So for the second one, what are the total number of substrings? So first it will be 4, 2, 1, 42, 4 to 1, 4 to 1, 21. Yes, that is it. So if we add all the substrings, we'll get 491. That is our answer. So the brute force for this is very simple. You just have to generate all the substrings for that string, and you just need to add all of them. So let's see. So for this particular substring, all the substring for this particular string, all the substrings for that is this 6, 7, as we have already seen that in the test case. So if we add all of them, you'll get 8421, which is indeed our correct answer. So let's see the code for the brute force approach. The time complexity for this one would be, as you know, the number of substrings is n into n plus 1 by 2. So if you consider n plus 1 by 2 as n, it would be n square. So n square, this is a n square solution. As you can see, two for loops we are using. So one for loop will go from 0 to n minus 1, 0 to n minus 1, which is this, which is index number 3. And this would go from I plus 1, because we don't want previous characters, we only want the forward characters. If you don't know this particular uh, code for generating all the substrings or the subsets, it's very easy. You just go through the code. If you don't understand, watch a YouTube video or something, you'll get the idea. This is very simple. This is for two for loops. It's very simple to generate all the substrings. I'm doing for grade equal to n because in the substring formula, the jth character in this thing is not included. So if you want from 0 to 3, you have to give 0 to 4. Then only you'll get this complete substring. So that is why I'm going till n, because for the last index, which is index number 3, I need 4 to get this particular substring in the Java language. So this is the brute force approach. This will not be accepted because it will give you TLE. In the constraint, it said that we need big of n, but this will also be accepted because the length of the string, if you see the constraint is 1 to 9, so 9 square is 81, which is constant only. But still, uh, we can do this operation much better because if we increase the string length, suppose it was 1000, so it will become 10 power 6, and it was 10,000, it would become 10 power 8, which would give you TLE. So this is not an efficient solution for strings which are uh, at a higher length size. So we'll see the optimal approach. So for this optimal approach, we'll use a queue and the sum. This is for the resulting, this is for the output. So initially we'll store all the characters in the queue. So first will be 6. This is the first in first out because queue, it's a queue. So 7, 6, 7, 5, 9. So we'll remove the top element, which is 6, and we'll bring this down. So 6, we have removed 6. 6 is here. So for 6, we will add its next character as well. So 6, 7. So we'll add here. We will add 6, 7 here. Okay, this is done. So we'll remove the next character, which is 7. 7. We will take 7's next character. If we write the 7, 5, 9. 7's next character is 5. So we'll add 5 and we'll push it to the queue. Now the queue will contain these characters. Now we will remove the top element, which is 5. 5. The next character to 5 is 9. So we'll add 9 and we will add this to the queue. We will add 59. Now the top element, if you remove the top element, we'll get 9. But 9, you don't have any other character to the left, so we don't do anything to this. We'll move the rest of the characters. So now on top is 67, so I'll remove this. 67, 67 this, and the next character is 5, so we'll add 5. We'll add 5 and it will become 675. 675. We'll remove the top element. 75 and the next is 9, so we'll add 9. So it will become 579. 5759, sorry, 759. So if you remove the top element, you'll get 59. 59. 59 next character is nothing, so we don't do anything. We move these two characters. So 657. If we remove 657 from the queue, 675, we'll add the next character, which is 9, and push it to the queue. 6759. 6759. And you remove the top element, which is 759. 759. There is no other character to 759. There is no other character to the right of it, so we don't add anything, and we remove the top element. So while removing, we will add to the sum, and while pushing, we'll add the next character to that substring and we'll push it to the queue. Let's do another dry run for a different string. But instead of storing strings, which is substring, it would be very inefficient because string in Java is not efficient enough. So we'll directly store the starting index and the ending index so that we can do s dot substring built-in function to get the substring at runtime. So we'll store the pair values. So initially we'll store all the characters. So for 1 it will be starting index will be 0, ending index is also 0. So for 2, 1, 2, 3, 4, 5. For 2 it will be 1, comma 1. It will be 2, comma 2, 3, comma 3, 4, comma 4. We have added all the characters to the queue. We'll remove the first character. which is 0 comma 0. You will write it down 0 comma 0, and it's starting from 0, ending at 0. But we can, if you see here, this is 0, 1, 2, 3, 4. If you see ending index plus 1 is valid, so we can increase the substring length. So we'll write here 1 and we'll push it to the queue. We will push the rest of the characters. We will remove this 1 comma 1, and we'll see if ending index plus 1 exists. Yes, it exists, so we'll increase this. It will become 2. So the meaning of 1 comma 2 is that we are taking this substring. Meaning of 1 comma 3 is we'll take this substring. So instead of storing strings here, we are storing the starting index as well as the ending index, so that we can directly use the inbuilt function substring to get the substring and then add it to the results. So while we are removing it, so for this particular index, we'll remove this and we'll add it to the sum. First, we'll remove 2 comma 2. 2 comma 2 means we are starting at 2, ending at 2, which is this. So we'll add 3. So and we'll check ending index plus 1 exists. Yes, it exists. So we'll increase and it will become 3. We'll move it to the queue. So we'll move it to the queue. And similarly, we do the same for every other character. So if we take 3 comma 3, starting from 3, ending at 3, so it will be 4. We'll add 4 and it will check if 3 comma 3 plus 1 exists, ending plus 1, it exists. So we'll increase this. It will become 4 and we'll push it to the queue, and this will happen till we reach the end of the iterations. All the substrings we have seen all the substrings, and there is nothing to add more to the queue. So that is where we stop and we return the sum value. So let's see the code. It's very easy. So in Java, you don't have a pair function or a pair value. In C++, you have inbuilt, but in Java, you have to make a static class because it's in the static function. So in starting index, ending index, I have explained already. So we'll make a sum variable, we'll make a queue. It will store pair values, not substrings. So initially we are adding all the characters 1, 2, 3, 4, 5, 5. So 0, 1, 2, 3, 4. So we are adding that index and as the starting as well as the ending index. So I've explained that also in the dry run. So in the after starting the while loop, we check if the queue is not empty. While the queue is not empty, we'll do all this iteration. Once it becomes empty, which means we have gone through all the particular all the substrings, that means we have exhausted through all the substrings, so we'll return sum. So in this, we'll remove the current pair from the top. I've explained that already. We'll remove the top element from the queue. We will take the starting and ending index, and we'll make a substring for that because it's indices. We want the value of that substring. So let's suppose the starting index was 0 and index is 3, which means we need this particular substring. We need this particular substring's value, which is 1, 2, 3, 4. So we have to make this as string in Java. Substring, we have to make that, and then we have to do a function called integer.parseInt. You'll get the value of this particular string. So after getting the string value, we'll add it to sum, and we'll check if the ending index plus 1 is less than string.length. For this particular test case, if we take 0, 1, 2, 3, 4, which is 1, 2, 3, 4, 5, this is the string and this is the indices. If you see here, for the last, which is 0 comma 4, there will be no next element because 4 plus 1 is equal to n, which is the size of the length. So we don't add 0 comma 5 to the queue. So that is where we end the loop, and we add if n plus 1 exists, so we add that particular substring value, and then after everything, after going through every substring, we return the sum value. So this is the complete code. As I'll explain you the time complexity as well. So time complexity is big O of n, because we are going big O of n because we are only storing 4 elements or the number of strings at a particular time. So if you take for this particular test case, at any given time in the queue only 5 elements will be present. So for the first one it will be 0 comma 0, 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4. So for the next iteration we'll remove this, so it will become 4, and then we'll add. What will we add? We'll first remove that 0 comma 0 will remove. Ending index plus 1 exists, so we'll make it 1 and we'll add it. So before adding, we'll shift the queue and we'll add 0 comma 1. So if you see, at any given time we are only going to deal with n number of characters, substrings. So you can say the time complexity big O of n, and the space is also big O of n. Here n is 9, so it will be almost big O of 1. So the constant space, and the this is also very small, so but still, according to the question, if you see, it's big O of n and big O of 1. So this is the time and space complexity for this particular approach. Hope you understand, and if you understand, please like, share and subscribe to my channel. Thank you for watching.